Recording in progress. Hi, students. In this lecture, I am going to discuss friction. Let us see first the list of concepts. So, first, I am going to discuss what is the definition, then types of friction, calculation of friction, angle of friction, and finally, a rough inclined plane. Let us see first what is definition. Let us consider a block is placed on a rough surface which is horizontal. A block is placed on a rough surface which is horizontal. Now block is at rest. Block is at rest. See, according to Newton's first law, if a body is at rest, net force on that body should be zero. Let us focus now number of forces that are acting on the block. So take free body diagram. It is mg downwards, normal reaction upwards. So weight is because of gravity. Normal reaction is because of the contact. Normal reaction is because of contact. Now see carefully. Condition given that block is not moving. Therefore, net force must be zero according to Newton's first law. So from this we can say normal reaction is a balancing mg because net force is zero. Now let us assume a force is applied horizontally. A force is applied horizontally on the block. Let us take this force is changing with the time. Let us take it is equal to 3t. It is a variable force. Assume that at t equal to 5 seconds, block moves. At t equal to 5 seconds, block moves. Now see carefully. Up to 5 seconds, block is not moving. That means, see, when t equal to 0, F equal to 0. Block not moving. So net force equal to 0. So N is balanced by mg. There is no other force act, right? Let us take when t equal to 1 second. Still block is at rest because condition is given that when t equal to 5 seconds, block moves. So when t equal to 1 second, F equal to 3 Newton, but block is not moving. That means there must be some other force which is balancing this applied force. Since this force is now horizontal, there must be a force which is horizontal and opposite to the direction of this applied force. So here, because of the contact, there must be some other force because that is the only possibility, right? Normal reaction upwards, mg downwards. So only because of the contact, there must be some other force which is balancing this force. And that force we are calling as friction. This is known as friction. You can see this friction is because of contact. Normal reaction also because of contact. So we are saying that these two are components of contact force. I am repeating. These two are components of contact force. That means contact force is given by, since between these two vectors angle is 90, resultant F square plus N square. This is a contact force. So we are saying that normal reaction and friction are two components of contact force. So friction is defined as the parallel component of contact force. I am repeating. Friction is defined as the parallel component of contact force. Now see carefully. When F equal to 0 means when T equal to 0, this force was 0 because net force equal to 0. When T equal to 1 second, F equal to 3 Newton, this force also equal to 3 Newton because block is not moving up to 5 seconds. So up to 5 seconds, net force must be 0. If T equal to 2 seconds, this becomes 6 Newton, then this also becomes 6 Newton. If T equal to 3 seconds, this becomes now 9 Newton. This also becomes 9 Newton. Like this, up to T equal to 5 seconds, this force is equal to the magnitude of this force. Why? Magnitude means directions are opposite. Okay. So when block is about to move, this will be equal to 15. Okay. So here, when block is at rest, then that friction is called static friction. When block is at rest, the frictional force is called static friction. Okay. And the maximum value of static friction, it is called limiting friction. So in this problem, block is moving when t equal to 5 seconds. Means in this problem, maximum static friction is a 15 Newton. Right? 5 3 is 15. So this is known as limiting friction. This is known as limiting friction. Now see once again, condition 1. Whenever block is at rest, with respect to the contact surface, then friction is called static. So here there is one misconcept like static friction means block must be at rest. This is a misconcept. The reason is, I will take one example to get more clarity. Let us take let us take block on block. Let us take block on block. Suppose we apply force on lower block. Assume that both the blocks are moving as a whole. It means there is no slipping between the blocks. We are applying force on lower block. These two blocks are moving as a whole. There is no slipping between the blocks. So now what I am saying is upper block is moving, but its velocity is 0 with respect to lower block. Means this is at rest with respect to lower block. Okay. Therefore, frictional force by lower block on upper block is static. Okay. Frictional force by the lower block on upper block is static. Or we can say frictional force by upper block on lower block is static. So we are saying that friction is static if a block is at rest with respect to the contact surface. I am repeating. We say that friction is static if a block is at rest with respect to the contact surface. That means block may be moving. Block may be moving, but it is at rest with respect to contact surface. Example is now this case, okay? So when we are saying static friction, it doesn't mean that block is at rest. So what we can say is block is at rest with respect to the contact surface. So whenever we are saying static friction. Block may be at rest, block may be moving. This is what we have to keep in mind. Next, and see one more interesting point here regarding static friction. T0, F0. When F is 0, frictional force 0. When T equal to 1, F equal to 3. Static friction is 3 Newton. When T equal to 2 seconds, F equal to 6. Then frictional force is 6 Newton. When T equal to 3, F is 9. Frictional force is 9. Right? That means static friction is self-adjusting. What's the condition? Static friction is self-adjusting. And how long it can adjust? Then we say that, see here, when t equal to 5 seconds, block moves. This is now condition given. That means in this problem, frictional force means static friction can reach up to 15 Newton. Okay. So in this problem, maximum value of static friction is 15 Newton. And this is the called limiting friction. This is called limiting friction. If you apply force slightly greater than 15, if you apply force slightly greater than 15, block comes into motion. Then that friction is called kinetic friction or sliding friction or dynamic friction. Okay. So let us now first focus on static friction. So regarding static friction, first we have discussed what is it. Block is at rest with respect to contact surface. So it doesn't mean that a block is not moving. Okay. This is the example for that. Block is moving, but not slipping on this one. Next, here one more thing we have observed that static friction is self-adjusting. It can adjust. And its maximum value is known as limiting friction. Okay. Now see carefully. In this problem, according to the given data, limiting value 15. Okay. Now observe that if we are keeping one more block on this block, just imagine this is a block. We have to apply in this problem slightly greater than 15 Newton block comes into motion. Just imagine a person sitting on the block. Now we have to apply more force to move the block. See where change is coming. When a person sitting on this block, at the contact, normal reaction is increased, right? Because at this contact by ground, normal reaction supports, which is balancing weight of the person and this block. So when a person sitting on the block, it becomes more difficult to move the block. So if you want to move the block, we have to apply more force. Suppose a person weight is more, we have to apply more force. Person weight is less, we have to apply less force to bring this system into motion. That means limiting friction depends on normal reaction. So limiting friction proportional to normal reaction. That means if block is having less mass, we can move the block with less force. If block having more mass, we have to apply more force. That means this limiting value is proportional to normal reaction. More is the normal reaction, more is the limiting friction. Because normal reaction is depending on weight. Okay. So from here, what I'm writing is this limiting friction is equal to some constant into normal reaction. And this constant is known as coefficient of static friction. It is known as coefficient of coefficient of static friction. So it is a constant. It is a constant. Okay. More is the normal reaction, more is the limiting friction, right? This is a constant. So basing on this point, you may expect some questions like, see from here what we can say, mu s equal to F limiting upon normal reaction. Suppose question is given like this. Weight of the block is doubled. Weight of the block is doubled. Then what happens to mu s? Okay. So here we have to keep in mind when weight is doubled, limiting friction also becomes doubled. So ratio remains same. But there is a possibility of making a mistake like when weight is doubled, normal reaction is doubled, so mu s becomes a half. So this is a misconcept. We have to keep in mind that when normal reaction is doubled, limiting friction also doubled. So that ratio is a constant. Okay. Right. So we have learned that first of all, what is a static friction? If a body is at rest with respect to contact surface, friction is static. Okay. That means body may be in motion. Next, static friction is self-adjusting. Static friction is self-adjusting. So its range is its range is from 0 to, this is actually closed interval. It is a closed interval 0 to F limiting. F limiting means maximum static friction, okay, which is given by mu s into normal reaction, okay. And here we have to keep one more point in mind. This limiting friction is not depending on the area. Suppose I'm taking the same block for same mass, but having more width means more area. I'm taking like this. There's a block of mass here. I'm taking one more block of same mass, but having more area of contact. So I have taken two blocks of same masses. In both the cases, normal reaction same, which is equal to mg. But in one case, area of contact is less. Other case, area of contact is more. But in both the cases, normal reaction is the same. That means in both the cases, limiting friction is the same. Getting it? So here what I'm saying is that limiting friction is not depending on area of contact. Or we can say friction is not depending on area of contact. It depends on normal reaction. Okay? Right. Next, once a body comes into motion, then friction is called kinetic. It is called kinetic friction or sliding friction or dynamic friction. And that value is given by Fk equal to mu k into normal reaction. Okay. So coming to kinetic friction, there is no confusion. First, we have to find normal reaction. Once it is known, multiply that with coefficient of kinetic friction. So here mu s coefficient of static friction. Here mu k coefficient of kinetic friction. Okay. So only difficulty is calculating static friction because it can have any value from 0 to limiting value. So we must be very careful while calculating static friction. Okay. And next here one more point. Mu k value. Mu s is always greater than mu k. So from this what I can say is limiting friction limiting friction is always greater than kinetic friction. See how to understand this point. In this problem, we have to apply 15 Newton to bring the block into motion. In this problem, we have to apply 15 Newton to bring the block into motion. But once a block comes into motion, to maintain constant velocity, no need to apply 15 Newton. With lesser force, we can maintain constant velocity. The reason is that once a body comes into motion, friction becomes a kinetic. And since mu k less than mu s, frictional force means kinetic friction is less than limiting friction. So if we can apply this force, then net force becomes zero. Okay. And here, if you draw graph between applied force and frictional force, see how graph comes. Let us draw graph between right. Now see carefully. I want to plot a graph between frictional force and normal reaction. Sorry, frictional force and applied force. Let us take this is now frictional force. This is frictional force. And this is applied force. This is applied force. So see carefully, up to 5 seconds means in this problem, up to 5 seconds, this applied force and frictional force both have same magnitudes, right? Because up to 5 seconds, block was not moving. Therefore, applied force, it was balanced by frictional force. So both are numerically equal. So you can take a graph here, which is a straight line. It makes angle 45. Students see carefully why angle 45. Because F equal to F means I am equating modulus values. Frictional force, balancing, applied force. That's why angle equal to 45. Let us take somewhere here. This is a corresponding frictional force. Corresponding frictional force. This is what we call limiting friction. Okay. And once block comes into motion, once block comes into motion, we can see block comes into motion immediately, it becomes a constant. Okay. And that is known as a kinetic friction, which is a constant, which is a constant. That corresponding one is known as kinetic friction. We can see a sudden change. Okay. It will change immediately. You can see here slope up to here. So in this problem, when t equal to 5 seconds, t equal to 5 seconds, or let us take here, okay, t equal to 5 seconds, it is reaching 15. Just after that, immediately changing to a constant value. Means after 5 seconds, frictional force is a constant, which is kinetic friction. So when you plot a graph between applied force and frictional force, it is a straight line passing through origin whose slope equal to 1. because slope equal to, it is tan 45, slope is 1. And just after crossing, or you can say just after block comes into motion, its friction becomes immediately constant, which is a kinetic friction. Okay, so slope equal to 1. Okay, so coming to kinetic friction, there is no confusion. Simply multiply mu k value with normal reaction. But while taking static, it can have any value from 0 to limiting value. So while we are making calculation of limiting friction, sorry, while making calculation for static friction, we should be very careful. Okay. See till now what we have discussed. So first we have discussed definition of friction. It is defined as the parallel component of contact force. Okay. Means it is a parallel to the contact surface. Next, there are two types, static and kinetic. Static means block is at rest with respect to the contact surface. It doesn't mean that block is at rest. Okay, block may be moving, right? Next, we have discussed that this static friction is a self-adjusting. Range is 0 to limiting value. Okay, limiting value means maximum static friction, which is proportional to normal reaction. And that proportionality constant is known as coefficient of static friction, right? Next, in the same way, once body comes into motion, then friction is called kinetic, and that is equal to mu k into n, where mu k is coefficient of kinetic friction, and mu s is always greater than mu k. That means limiting value is always greater than kinetic value. But remember, static friction static friction may be greater than kinetic friction, or may be equal to kinetic friction, or may be less than kinetic friction. Okay. For example, take one small example like here we have taken limiting value 50. Suppose kinetic friction is now, let us take it as a 12 Newton. Okay. That means frictional force, static friction can be 12, can be greater than 12, can be less than 12. Okay. So static friction may be greater than kinetic, may be less than kinetic, may be equal to kinetic, but limiting value always greater than kinetic friction, because limiting value how much? 15. In this case, kinetic how much? 12. Okay. So these points we have to keep in mind. And one more thing, mu s and mu k values. Generally, their values are less than 1. It doesn't mean that their values cannot be greater than 1. That means their values can be greater than 1 also. But in most of the cases, their values are less than 1. Okay. So their values can be greater than 1 also. Let us see one's notes for this. See what we have discussed till now. First definition part. It is the parallel component of contact force. It always opposes the relative motion. It always opposes the relative motion. It may support the motion. It is a frame independent. Let us see once these two points. What meaning of these two? Always opposes relative motion. It may support the motion. It is a frame independent. See once. So here we have seen when block is at rest, we are applying a force, block is not moving. That means frictional force. See, because of this applied force, block is trying to move right side. Block is trying to move right side, but not moving. That means frictional force is now left side. It is opposing the motion or it is opposing the relative motion. Block is trying to move with respect to surface. Friction opposes that relative motion. If block is moving, friction is the kinetic. Motion is right side, but friction is left side. It opposes relative motion. And next point, it may support motion. See meaning of that? Meaning of supporting motion. Let us take block on block. If you apply force on lower block, you can see that upper block also moves along with the lower block. And remember why upper block is moving. Upper block is moving because of the frictional force. If I am taking free body diagram, see force is acting on lower block. Force is acting on upper block and lower block. Upper block. Upper block applied force. When we are applying force right side, upper block also moves right side and it moves because of friction. Students, you have to see carefully. Upper block is moving because of the friction. Means because of the friction only upper block is moving. That means it is supporting the motion of the upper block, but it is opposing motion of the lower block. So see carefully. Upper block is moving because of frictional force. That means it is supporting the motion of upper block. The meaning of that. Next, coming to here. With respect to upper block, lower block tries to move right side. I am repeating. With respect to upper block, lower block is trying to move right side. That's why on lower block, frictional force is acting left side. It opposes relative motion, the meaning of that. And this is example for friction may support the motion. Upper block is moving because of friction only. So friction always opposes relative motion. Friction may support the motion. And next thing, this force is not depending on the frame. That means if a person sees now this system from ground to frame, suppose there is a person in a moving frame. Suppose this is a car which is moving or which is accelerating. This is a car. For this person also, frictional force will be same. For this person who is standing on ground, for this person also, frictional value same. That means frictional force is not depending on the frame. From any frame, value same. The meaning of frame independent. Okay. Right. Next. If a body is at rest with respect to the contact surface, then it is static. It is self-adjusting. Okay. And maximum static friction is called limiting friction. It is independent of area of contact. Its range is from 0 to limiting friction. If a body is moving with respect to contact surface, then friction is kinetic or sliding or dynamic. Static friction may not be always greater than kinetic friction. This point we have discussed, right? Limiting friction is always greater than kinetic friction. This also we have discussed. Coefficient of static friction and kinetic friction may be greater than 1. Okay. This point also we have discussed. Means in most of the cases, their values are less than 1. But their values can be greater than 1 also. The meaning of that. I hope you got a clarity on the concept. In the next one, we can discuss problems basing on this concept. Right?